So I was asked to make a short video about the unit circle. And when we take a look at the unit circle, we do have 4 points that we should know automatically, okay? And they're on the X and Y axis. Now, this point on the X and Y axis, because it's the unit circle, I have a radius of 1. I'll always have a radius of 1. But if I come to this point, I see 1, 0, and I know that this is 0 degrees or 360 degrees, okay? So if I ask for the cosine, now ordered pairs that fall on here always come in the order of cosine and sine. So if I said, what's the cosine of 0 degrees, it would be 1. If I said, what's the sine of 0 degrees, the answer would be 0. If I came up here to 180 degrees, I start to have the same situation. It's the ordered pair 0, 1, and then the cosine of 90 degrees would in fact be 0. The sine of 90 degrees would in fact be 1. So by doing this, you start to build the unit circle. But what I think is more important is to know that spots on the unit circle are the ordered pairs of cosine and sine. Now, for these 4 points, that's great. And I know a lot of you have the rest of the unit circle, and you'd have the ordered pair here for 30 degrees, and the cosine would be the first one, and the sine would be the second one. But I think it's important to know where this comes from instead of trying to memorize this whole circle. So I'm now going to take a look at the rest of the unit circle. Its parts come from the 30, 60, 90 triangle and the 45, 45, 90 triangle. Now the values for the 45, 45, 90 are the easy ones, because if this guy is of length 1, this guy has to be of length 1, and I do 1 squared plus 1 squared equals that distance, okay? And I know that that ends up being squared, so I get 2 equals d squared, or d equals the square root of 2. So that's where my 45, 45, 90 comes from. 30, 60 is a little more involved, but a lot of people will just memorize it. The opposite to 30 is the 1, square root of 3 is opposite 60, and the 2 is the hypotenuse. All right, so let's come down and talk next about a reference angle. So if I asked you to tell me about 210 degrees, I would first traverse 180 degrees and then another 30. So my reference angle would be this fellow right here, okay? Reference angles always go back to the x-axis. So if I was drawing something over in the first quadrant, this angle measure, I would draw the reference angle back to the x-axis. So now for 210 degrees, I'm going to use my 30-degree triangle. And as I start to put in the values, opposite 30 is 1, square root of 3, and 2. And by location, this is actually a negative value. And by location, this is also a negative value, okay? And what results here is something that looks like this: all sine, tangent, cosine. And some people will say all spiders taste crunchy. And what this means is all of the measures in this first quadrant are going to be positive. When I go to the second quadrant, if I draw a reference angle, I see that this value is negative and this is positive. So when I go to find the sine, okay, it's going to be opposite over hypotenuse. It's going to give me a positive value. The cosine and the tangent would both be negative. If I came down in this quadrant, the third quadrant, only the tangent is positive. And if I came over to the fourth quadrant, only the cosine is positive. So this all spiders taste crunchy is the quadrants where that angle measure is positive. All right, so now let's put this into play. Instead of memorizing the unit circle, if I asked you for the cosine of 135 degrees, I know that all the way around is 180. So this is going to be 45 degrees short. So my reference angle is going to be 45, which is 1, 1, square root of 2. But by location, this is negative. So when I want the cosine of 135 degrees, cosine is adjacent over hypotenuse, which is -1 over the square root of 2. If I ask for the tangent of 210 degrees, I draw, that's 180 plus another 30. So I'm going to draw my 30 degrees. Okay, I put in 1 square root of 3, 2 by location. That's a negative, and that's a negative. So if I want the tangent, I want opposite over adjacent, a negative over a negative. Oh yeah, that's that whole positive thing. I get 1 over the square root of 3. Again, if I rationalize these, this would become negative square root of 2 over 2. This would become square root of 3 over 3. Okay, sine of 60 degrees. I'm in the first quadrant. I draw my 60 degrees. Here's 30. Opposite 30 is 1, square root of 3, and 2. So the sine is, again, SOHCAHTOA. Sine is opposite over hypotenuse. So I would get the value of the square root of 3 over 2. And a lot of the problems you're going to be asked to do these say, find the exact value. This is what we're looking for. We're not looking for something you can put in your calculator. So all of these values, if I took them and calculated them all and put them on this circle, I would have all of the ordered pairs. Again, I'm not so much as concerned that you memorize this. I mean, you need to know that all the ordered pairs are cosine, sine, and these 4 come out of here. But the rest, I would go back to my 30, 60, 90, and my 45, 45, 90 triangles and go from there. Hope that helps.